Hi. In this video, I'm going to demonstrate some of the R functions that you'll need for this first lab. In this first lab, you're doing sort of a typical statistics problem. You'll have data from two samples, and you're going to investigate whether or not the evidence you have from looking at the means of those two samples is sufficient to prove that there's a difference between the two population means, populations from which those samples come. So in your lab, the samples are from a survey I did of BMCC students about their happiness levels and whether or not they had tattoos and whether or not they go to religious services. But that's not the data set I'm going to use in my example. Let me show you that. But the same R functions apply and the same techniques, basically. So what I'm looking for. Um, so here's my data set. I do a lot of work looking at climate change, and so this has to do with the salinity of ocean water. I spent hours looking for a data set on the salinity in the past versus the salinity in the present so I could show the effect of climate change. So I never came up with that. So what I have is just some data, a snapshot in the present day. This is a lot of countries. My guess is that the researcher was Canadian because they put Canada first, and then eventually it gets alphabetical. Yeah. So what we're going to do is we're going to compare two countries. I've decided to compare the United States versus Brazil, and the salinity of the ocean water at various ports in each of those countries. Sort of climate change, because I think Brazil is a little warmer, so I'm trying to say that in warmer places there's more salinity, saltier water. What's interesting about this file is it's in the format that R likes, called a data frame. Across the top, it lists the variable names. I'm going to focus a lot on the annual salinity. And then each row is a case for all of those variables. So what we're going to do back in R is pick out just the data that we need from this. That's the annual salinity for the USA and the annual salinity levels for all the ports in Brazil. And then we'll analyze those two samples. That's the plan. Go back to R. Okay, so I've listed some of the functions that we're going to use up here. And then down in the console, we'll run some stuff. So the first thing you need to do is get the data set into R. So you can look to see what the working directory is. That is where R is going to look for files. That's not what I want. So right now it's set to look on my OneDrive. That's not what I want. And then what I want is up here. So I can copy and paste stuff from here down into the console. And that worked. And now, so I'm going to define a data frame called ports. And ports is going to be assigned the data that's in that CSV file, which is called global ports. That's if I wanted to list the files in the current directory, I could just do dir and see the files there if I wasn't sure what the name was, and then I could get that. Okay, so now that worked. There are 7,339 observations of the ports around the world and 37 variables for each one. Okay, so now, as I said, let's extract just the part of that for my little hypothesis, which is I want US salinity. I'm going to do something clever here. I'm including the units of measure in my variable name because what we're going to do here is the basic statistical analysis needed to investigate this hypothesis. And so the descriptive statistics part of this course is based on center, shape, and spread. That's what you want to know about this data set. I want to know what's the mean, that's the center, how spread out the numbers are, that's the standard deviation, and by looking at the graph, I can determine the shape of the data's distribution. And I get a feel for, I'll put the graphs right next to each other to get a feel for the relationship between the values in USA and versus Brazil. Okay, so let's extract the information that I need. So I'm going to define this variable for the US salinity level, and I'm going to use the subset command. I'm going to make a new data frame that's just a subset, a part of the old one, and in this case, so I say what the big set is, what the universe is, and then what I want country equals, it's two equal signs, good old USA. Okay, and that's going to create a new data frame with just the USA's ports. And now I just need one particular variable for that. So $, and put the variable, which is annual salinity. And look at that, it worked. This is a numerical variable with 350 entries. That shows me the first couple of them. And now if I want to be lazy, if I just do the up arrow, it gives me that. I'm going to call this Brazil salinity. And all I need here is BRA, and everything else is good. I see that there's only 69 ports in Brazil. Great. So let's do the mean of the US salinity. And compare that to the mean of the Brazil salinity. So that pops up for me. And so salinity is slightly higher in Brazil, where it's warmer. That was my theory, on average. Now, is that difference significant? Well, depends on a couple things. It depends on how much variation there is within each of these data sets. And the answer is a lot, right? The standard deviation of 10.445 means the average salinity level was 10 parts per thousand away from the mean salinity level in the United States. That's a huge amount of variation. It means the data is all over the place. I think the reason for that is that ports that are near the delta of a river will have lower salinity. I think that's it. I'm not sure though. And similar level of variation in Brazil. So typically, as a statistician, center, shape, and spread. The other thing that I typically report on is the sample size, but we know that from above we saw that this is going to be 350, I think. Yeah, and for Brazil 69. Okay, so the next thing I want to do is show the shape of the distribution. So that's a histogram. Histogram of US salinity. We can pick a color. This is the ocean. We'll make it blue. Yeah, let's have a look. Um, yeah, I did something sneaky there. This is exactly what I want, but I'm gonna have to go back and there. I have them side by side, and you really get a feel for those data sets, right? They're both sort of skewed to the left. Most of the values at the high end and just a couple of outliers on the low end. Uh, Brazil even more so than the United States. A big pile of values between 35 and 40 in Brazil. Yeah, I kind of um, skipped a step there because I did it before I started running this. And what I did was I split the plot window into two so that um, you could see the graph side by side. And let me just, I'll show that command that I used. I did this before I came into this. And so this has 2 rows and 1 column. And by doing that, that's how I partitioned the graphing window to get graphs side by side. So I ran that before I created these graphs. That's just absolutely beautiful, though. Okay. So the final thing we want to do here is the formal statistical test, which is called a t-test. So for the t-test, I'm going to specify my variables. And you can do a 1 variable t-test and test against a value, but here, of course, we're doing 2. So I think the US is less than Brazil. And we'll use a confidence level of 99%. And I think that's good. There it is. And so the t-value is negative 1.577. A significant difference is somewhere around 2. The p-value is 0.059. So at an alpha level of 0.01, we fail to reject the null hypothesis. The difference that we found is not significant. And why is that? Well, we have huge sample sizes, right? 350 ports. However, the variation was quite high. So because there was so much variation, I don't have confidence that this difference would hold up if I looked at different samples or more ports. But I've got a good feeling for the relationship between these 2 data sets. While the mean of in Brazil is higher, it's not significantly higher statistically. Oh, the only other thing I want to say about the histograms, I should have added a title. I am picky about that. And to do the title, you would put main better. And it has the units of measure on the bottom and nice descriptive titles. So that's it in a nutshell. Let me know if you have any questions. Hope you can do the same thing for just a different data set. Bye for now.